Hello, everyone. It's about time to our webinar. Thank you for your join for today's webinar. We were talking about predictive maintenance. My name is Stephen Wu. I'm currently working for DFI as Vice President of R&D Center. I hope everyone, no matter where you are doing well to prevent yourself being infected by coronavirus. What really concerns us and we really worry about us is we don't feel where the virus is, we don't see the virus. So only we can do is taking some preventive action, like keep social distance, measure body temperature, putting on mask when necessary. So think about if you are a production manager or company's operating officer. You are managing hundreds and thousands of machines, produce the product for your company. What worry about you? I think definitely some of the machines stop working and your production plant cannot keep. So we will talk about maintenance topic. There's a survey performed by PwC. So when the company are really concerned and plan to implement regular maintenance, what they think about. The first item ranking 47% people taking the advantage to keep the machine uptime very well. The second area is people concerned if the machine a problem, it may stop working, it may produce some defect product, so it can introduce really high cost about the quality issue. And some other areas, customer are really concerned if I can make full use of the lifetime of the machine. These machines are really expensive equipment. So what do people know or do the maintenance job? In a normal practice, we normally recruit dedicate a professional expert to take serve this job, but some other company maybe don't have this resources in organization, so they will do some very passive way, repair the machine until the machine stop working. The other more proactive company maybe do some planned maintenance, so they normally schedule repair spare parts in a certain amount of time. But the problem is if you do it too early and you are wasting the spare parts. Maybe it's still working really good for some time. But if you do it too late, your machine already stopped working, you got a big problem, your machine production line stop and you cannot keep your production plant work. So the best scenario is we do it at the right time and the right place. So how do we do the maintenance in the right time and right place? You start to search for special pattern or signal. We call it the signal. So let's take a chart for the quality. So the x-axis is the time you install the machine and you operate the machine. And the y-axis is the potential failure. It may happen. So just taking the car experience, if you bad luck, you buy really bad quality of a car. The next day you get the car, it start give you trouble, so you start to repair it. So that is, we call it the early failure. But if you are good luck, the car really perform well and it keep life running for a long time. But eventually the car will still stop working at the end of its life. So the opportunity window for maintenance is in this period. So doing the regular, correct maintenance, you can make sure your car driving in a good condition. So how do we determine when to perform predictive maintenance? So there's no magic for expert. They just know what the machine are going to be bad, in bad condition. So they have their knowledge. They normally will feel, touch the motor, maybe a compressor or chiller. They touch, feel the chiller vibrate or not. Some other time they may be doing measurement, measure the temperature if the temperature got too high. Some other expert maybe will hear if there are very big noise coming out from the motor or machine. So these are what the skill they use. So the more abnormal condition, event, or signal, we call it the signal, and the higher probability your machine are going to be in bad condition soon. So this is the basic techniques we use to predict if the failure can happen. So you can do many different skill or different way to capture this event or signal. The very straightforward, simple way is by expert. They just use their visual inspection. So they use the prior practice, they use their experience, they use their knowledge to determine if this machine or this motor cheater are going to be bad. The second way is they do a little bit accurate. They use the instrumentation like a temperature sensor. They measure the vibration. They take the current draw from the motor if that is in a not abnormal condition. The third level is we do it even better. We have a continuous monitoring sensor. We collect the data and keep giving us some status report. So we know if the motor, cheater, or machine are under expected condition. The best or the extreme way is we have a better mechanism we call the predictive maintenance. So with predictive maintenance, you have a sensor, you have some algorithm to determine if the machine or the monitoring devices are in good condition. So with this extreme method of predictive maintenance, you can have a chance to even capture some failure that you never expected it will happen. So this is really best method. Here's some distribution chart. There are very small amount of company that never do any maintenance, 3%. So the level 1 maintenance, there are 27% in the market. 36% they do the level 2 with instrumentation. 22% have the real-time monitoring system in place. Only 11% perform predictive maintenance. But really, predictive maintenance is not a rocket science. So let's take a look at what we can implement a predictive maintenance. The fundamental way is you have to transform the physical world information, signal, event, status into some data. So I call it transform from physical to cyber. So if you have a sensor can do this job, a sensor can convert the vibration, convert the temperature, convert the acoustic noise, that is the physical signal, into the data. So with the data, you can do many jobs to determine if the data indicates some kind of failure. So before you doing this conversion, it's better you follow the 5 step shown here. The first step is you will definitely first identify which important assets you want to monitor in. So you don't normally monitor some less value machine, but you will focus only on high value machine or critical machine. Second area is you collect the data and convert it into useful data, filter the data with some meaning, so you can gather the data. Then you can analyze the data and predict, capture the signal in the, we call it the abnormal condition. Then you can do some management work and so forth. So this is just a concept. You know it, not that difficult. You have a sensor, you have some computer, embedded computer do this job. So to constructing a system, we have some practice collaborate with one of the Taiwanese famous university called Cheng Kung University, which is the major in industrial area. So they have many experts. So DFI collaborate with Cheng Kung University to build such a system. We call it IPM, Intelligent predictive maintenance system. So let's take a look at the bottom side. So what you need to do is install embedded computer. We call the CPA. So within the CPA, we have a software stack installed in the CPA. So this software stack will take in the data from the sensor. So there's we call the generic sensor driver. So this driver can be a CAN bus, can be a serial bus, Modbus, OPC UA, and so forth. So with this software stack, you can collect your machine status through the like a temperature sensor, vibration sensor, acoustic noise sensor, and so forth. So with this data, we will put it together into the database. So we have another module can do the predicted analysis. So on the upper right side, you will see a simple model, how we predict a failure. I don't detail every block here. It's just simply some statistical method, clustering or classification, some accompanied with some AI, so you can produce some signal. And this signal can really stand same knowledge or same experience like your expert doing the maintenance for the company. So with this system, you are no longer need recruit an expert in your company doing this job. This computer with this IPM system can do the job for you. What the beauty of this system is just produce very simple chart or indicator to your average employee. He can easily to know if your machine are going to be bad. So the output screen will look like the right bottom screen. There's an indicator. If it is in a bad condition, it will show you a red color. If it is in a good condition, just give you a green color. So if you want to know a further detail, you can drill into the chart. It gives you the curve, what time the failure can happen and how long it will last. So I think overall, this system just helped you to construct the workable predictive maintenance methodology in your company. So regardless how many machines, you can use a similar methodology to implement an efficient way to prevent any potential failure. So with this basic techniques, it's not difficult to install. With expert, we help, we can deploy the system to your company. Based on this, you can do even more beyond the predictive maintenance. Actually, this chart is give you some understanding. So in the maintenance area, you can do many levels of different maintenance. The first level is you do only prescriptive prediction. So with prescriptive analysis, you can understand if your system is performed well or not. Go beyond that, you can do diagnostic analysis. With this analysis, a bit more data, you can understand why some machines are in better condition than the others, and why the elements are in a bad condition. So go beyond that, you do predictive maintenance. That is today's main focus. So you can predict when the potential defect failure can happen, maybe 1 day later, 1 week later, or 1 year later. But go beyond that, you can do even further step to do some action to correct the failure, potential failure. Even you know the failure can happen next week, but you don't really need to do repair or swapping the spare parts. You can do some correction and keep the condition still working with good condition. That is something we call the prescriptive analysis. So how to do that? We can easily just add in a software module to the system. I mentioned it earlier, IPM, Intelligent Predictive Maintenance System. So you add in a module we call the virtual metrology module, what is virtual metrology module? I will explain a little bit through this slide for you. If you look at the upper left corner, so in a normal way, when you produce a bottle, for instance, a PET bottle, so how do you know the bottle is good quality or bad? The normal way is you produce a batch, then you sample a couple of units, and you do the measurement if the bottle fit the size, if the transparency is good, if the shape is good. During the measurement, if you are not sure if the measurement result is good, if you keep producing the bottle, you have a potential defect product produced massively. So normally you will stop producing the bottle for a while until you got a measure result. But if you do this way, you will firstly, you need to sample and do measurement. That takes some time. Secondly, during the measurement, you stop produce, so you lost some production capacity. So with the virtual metrology, we can leverage the equipment for predictive maintenance. We can collect more data and produce some quality prediction. So we can leverage these techniques to predict the quality result. For instance, the bottle size, the bottle shape, by just the data analysis. So next slide, I will show you a demo or video how you can do that.
This is the AVM demo of the PET stretch blow molding machine. There are 3 scenarios including preform transferring mechanism, blow molding export, and the mean thickness prediction of each cavity. AVM is integrated with online measuring machine and printer to ensure the model freshness and follow-up material tracking. In the next scenario, after heating the preform, it is molding. The finished products are sent to the This is the AVM demo of the PET stretch blow molding machine. There are 3 scenarios including preform transferring mechanism, blow molding export, and the mean thickness prediction of each cavity. AVM is integrated with online measuring machine and printer to ensure the model freshness and follow-up material tracking. In the next scenario, after heating the preform, it is delivered to the clamping system for blow molding. The finished products are sent to the online measuring machine for metrology of. At the same time of outputting the products, the AVM system will display real-time prediction results,
we have some technical
and actual
problem.
metrology values are used for model tuning to assure model freshness. The original architecture adopted expensive online measuring machine for run-to-run control, which greatly increased the construction cost. AVM can replace the online measuring machine with periodically offline metrology to make sure the model freshness. With online machine, AVM can check the reliance index of the metrology values. The AVM technology can provide economical, online, and real-time total quality inspection on the run-to-run system to solve the problems of expensive measuring equipment and increase the reliability of actual measurement. Also, different tools can share the same measuring machine.
Okay, now you have probably a better understanding or basic idea about what is virtual metrology, or AVM stands for automatic virtual metrology. So I will use one slide to give you a little bit more about what is virtual metrology. So the basic idea is you have predictive maintenance, you have a sensor data for your machine, and along with the process data, you know how you design your product and some parameter. So put it all together, we can, using the predictive method, to produce the real output product, and along with the real measurement data, you only need a small set of measurement data. You can correct the prediction. So with all these two efforts, you don't really measure the output of the product, of the quality. You can use a predictive way to measure the result. So which stands for a concept, you have 100% test to your product quality. So this is give you a next level of quality control with just a small change to the current system I introduced you, the IPM. It's just a software module and taking extra measurement data. So this is a good system, give you some expandability, expansion capability. So we have doing some further enhancement on this system. So using the AI methodology. So this chart is just give you some idea how we improve the predictive accuracy. So we're using the AI inference engine. So there are training and model pre-trained by the cloud system. So with this result, we fit into the CPA box. What I mentioned earlier, this is the embedded box that put alongside with your machine. So inside the CPA, we have a module called the inference engine. So with the neural network, so we can calculate and calibrate the prediction result in higher accuracy. So put it all together, so this system can really keep good performance. And secondly, you are very flexible to expand function, just not limited to only predictive maintenance, give you the signal and predict when your machine will be failure. You can really measure the quality of your system, and you can do the improvement to the production capacity and yield rate. So if you are find interest for this solution, what DFI can help you is we collaborate with Cheng Kung University. This system is in ready packed in ready to use system. So if you have interest, we can help you to run the demo and do some field site testing. And DFI belong to a BenQ group company, so there are many experts from within the group. So we can leverage the expert from our group to help you to establish or deploy the predictive maintenance methodology. And DFI itself, we have produced many standard off-the-shelf embedded board. We have a box PC and the panel PC. So it depends on your needs. So we can customize the predictive maintenance in the right size, right cost to fit your need. Thank you for your attention for the webinar. If you have any question, don't hesitate to raise your question for now.